Hi there, you guys. This is a follow-up from your homework assignment on Tuesday night. It was on inverse trig functions, the introduction, and I've gotten a lot of questions on it, so I thought maybe I would go over some select problems from the book and just as a check to see if this clears up any questions you might have. So the first video you watched was a kind of a long explanation of where the domain restrictions come from, but essentially this is what you need to memorize when you're looking at inverse trig functions. Is the sine inverse is going to be restricted between negative pi over 2 and pi over 2. So you think of it as the first and fourth quadrants, but it's either going backwards or forward. Think of it that way. Between negative 2, pi over 2 and pi over 2. Cosine inverse is between 0 and pi, so the first and second quadrants. And tan inverse is essentially the same as sine inverse, between negative pi over 2 and pi over 2, so the first and fourth quadrants. That's what you need to remember. So when you have an answer to an inverse trig function, if it's written like this, there's only one answer. Okay, so let's look at number 9, for instance. I like to always rewrite these because an inverse function represents an angle. So I like to write it as sine of what angle equals negative 1/2, because we can wrap our brain around that a little better. So where is sine equal to negative 1/2, knowing your unit circle? There's actually 2 spots, but only one is defined as an inverse function. Sine is always your y value. Y is negative in the third and fourth. So there's actually 2 spots, but remember our domain restriction. Sine inverse is only defined in the first and fourth, so we know it's going to be in the fourth quadrant. Now, this is where people get mixed up. When there's a negative for a sine inverse, this is tricky because a lot of people say, oh, this is a pi over 6, so this is going to be 11 pi over 6. It's not 11 pi over 6, big mistake, because it has to lie between negative pi over 2 and pi over 2. So you think of it as going backwards. Okay, so it's negative pi over 6. Remember, that's just coterminal with 11 pi over 6, but just because of the way it's defined, the answer has to lie between these 2 values. This is something you kind of need to memorize. Okay, so cosine inverse being negative root 2 over 2. That, again, I like to rewrite as cosine of what angle is negative root 2 over 2. So we know it's going to be a 45-degree reference angle. Cosine represents an x value on your unit circle. So where is x negative? Second and third quadrants. But cosine inverse is only defined in first and second. So that means we know we're going to be in the second quadrant. Okay. 45-degree reference angle, so that is just going to be 3 pi over 4. Okay. And again, that lies between 0 and pi. All right, tangents are a little trickier. So tan inverse of negative root 3. So again, think of it as tangent of what angle equals negative root 3. So whenever you see something with a root 3 or root 3 over 3, we know that tangent is defined as sine over cosine, or y over x. So this guy, root 3, is coming from one of 2 ratios, either root 3 over 2 divided by 1/2, where that's my sine, that's my cosine, or the opposite, 1/2 over root 3 over 2. So which of these ratios reduces to negative root 3 over 2? You'll get faster at this, but it's this guy right here, right? Those would cancel. So we're looking at where sine is the root 3 over 2 and cosine is the 1/2, but it's negative. Again, tan inverse is defined between negative pi over 2 and pi over 2. Tangent's positive in the first, so it's got to be down here. Okay, and the coordinate is your x value, y value. So that's negative root 3 over 2. So what's that angle? Again, the common mistake is to think that that is 5 pi over 3, but that's not in our restricted domain. So we go backwards, right? It has to be between negative pi over 2 and pi over 2, so it's negative pi over 3. Again, same location as 5 pi over 3, but again, we just have to follow the rules and be between those two values, just how it's defined. Okay. Tan inverse of pi over 3 essentially, the root 3 is the same as this guy, same ratio, except we're up in the first quadrant, right? So tan inverse is positive, we're up here. And the coordinate is 1/2 root 3 over 2. So again, that's just going to be pi over 3. All right, let's look at these two right here, 25 and 26, where we do compositions of functions. When you see an inverse of some type of function to evaluate, first want to start on the inside. So we want to find sine of pi, knowing our unit circle is just where, what's the y value at pi? So what are we going to be at? That's -1, 0, so that's 0. So sine of pi is 0. So we want to find tan inverse of 0. So again, think of that as tangent of what angle equals 0. Well, tangent is always sine over cosine. So in order for a fraction to be equal to 0, that means sine has to equal 0. So where is the y value equal to 0? Well, it would be at either 0, pi, 2 pi, 3 pi, and so forth. But we need, again, this to lie between negative pi over 2 and pi over 2. So the only value that works is 0. At 0 radians, that would be the value. Okay. All right, another one. Work on the inside first. The sine of pi over 3, knowing our unit circle. =60° reference angle, so that is going to be root 3 over 2. So cosine inverse of root 3 over 2 is what we're trying to find. So cosine of what angle is root 3 over 2. Again, there are two values. Cosine's positive here and here, but cosine inverse is only defined in first and second. So we're talking the first quadrant, and that's pi over 6. All right, guys, I think I will break these up into a few videos since I don't want them to be too long. If you are looking for some additional practice, I'm going to do some more compositions in the next video and some of the word problems that I got a lot of questions on. So you can go ahead and look at the next video if you're interested in seeing more examples. I hope that was helpful and cleared up some of the misconceptions. The key is just memorizing these 3 domain restrictions, okay? Hope that helped, and good luck studying. Bye.